Hello all the students. So today's video is a continuation of our previous video wherein we studied the rules of inference for quantified statements or the rules of inference for the predicate logic. We've already studied two rules of inference which were the universal instantiation and the universal generalization. Now today we are going to continue with the remaining two rules, which are the rules of existential instantiation and the rule of existential generalization. Now what are these rules? So the third rule, that is the rule of existential instantiation, says that when there we can conclude that if for some x px holds, or there exists some x for which px is true, then we can say that there exists some c for which pc is true. In other words, when there is some element from the domain for which px is true, we can give it a name such as c. So we have to specifically find such elements c for which pc is true, and here c cannot be arbitrary. So whenever there exists some x for which px is true, therefore there exists some there exists some c for which pc is true. Now the fourth rule of inference, which is the existential generalization, it says that if there exists some c for which pc is true, then obviously there will exist some x for which px is true, because what does existential quantifier say? It says that even if for some value of x px is true, then px holds true for all. So that means if there exists some c for which pc is true, then we can conclude that there exists some x for which px is true. Now we will study a problem related to these two rules, that is the existential instantiation and the existential generalization. So let's look at the problem. Okay, so the problem here says that we have to show that if for some x, p of x and q of x in conjunction are true, then for some x px and for some x qx is also true. So we have been given this statement. This statement is already given to us and we have to prove this statement as valid or true. Okay, so let's start. The first step here is that we have already been provided with a premise which says that for all x, p of x and q of x in conjunction are true. So this is our first premise, right? Okay, now since for all x, p of x and qx are true, so as per the rule of existential instantiation, I can say that there exists some c for which p of c and q of c are also true. So I can write it down as p, c and qc is also true. So this is, I have applied existential instantiation from the first premise. So after applying existential instantiation on the first premise, I can say that if there exists some x for which px and qx are true, then there also exists some c for which pc and qc are true. Now we can further break them down. Since they are not written in the clause form, so I can break it down as pc separately and qc separately. So in my third step, I will break it down and I will write pc separately. So this is from which premise? This is from the second premise. Now I will apply existential generalization to the third premise, which says that if there exists some C for which PC is true, then there exists some X for which PX is true. So I will say that if PC is true, then there exists some X for which PX is true. So what have I done? I have applied existential generalization on my third premise. Okay, again I can write down QC separately here from the second premise, just like I wrote PC. So this QC I have written separately from where? From the second premise. So on this QC also I can apply the rule of existential generalization, which says that if there exists some C for which QC is true, then there also exists some X for which QX is true. So I can say if QC is true, then there exists some X for which QX is true. So this is existential generalization on the fifth premise. Okay, now there exists some X for which Px is true, and in the sixth premise I say that there exists some X for which Qx is true. I can combine the fourth and the sixth premise since they are written separately, so I can combine them using conjunction. So I can say that there exists some X for which Px is true and there exists some X for which Qx is true. So this is what I wanted to prove. So I have proved this statement to be valid or true. I have found out that this particular statement is valid through these steps. So these were the four rules of inference for predicate logic, which were the universal instantiation, the universal generalization, the existential instantiation, and the existential generalization.